Hello, I'm John Hemingway. Welcome back to Shropshire. Now, somebody asked in the comments recently, can you do a live instructional video on how to do a fecal egg count? The thing is this, I don't really do fecal egg counts anymore because I've got a machine that does them for me. But since you asked so nicely, I'll do it. Okay, so let's go. Things that you're going to need then, you find these around your house. You need some kitchen scales and you need a pot that will go on them, okay? You then need another pot, a beaker, a mug will do for this, so long as it is a dedicated mug, and a pipette. You then just need a big syringe and you need a sieve. I've got a special sieve for fecal egg counting, but a fine tea strainer will do the job just fine. You then need some flotation fluid. Well, this is just salt water. It is saturated salt solution. So all you do to make this is get water and keep dissolving salt in it until it stops dissolving. Then you've got saturated salt solution. And finally, you need a McMaster slide. This is one thing that you're not likely to have around the house. A McMaster slide is a special slide that's got a cavity in it, you see? And that fills up with fluid. And on the top layer of that cavity we have a grid etched, and we're going to explain what that's for in a minute. Finally, you are going to need a microscope capable of magnifying by 100 times. Now, this is pretty much any microscope that you're going to find. However, it's very helpful if the microscope you have has got a moving stage. This means that you can move the slide about underneath the lens as we go. So let's crack on with it. What do we need to do? We need to get our sample. We want a fresh sample from our animal and we're going to weigh out 3 grams. Ideally, we want to take our 3 grams from different parts of the sample we've collected. Now, let's hold up a minute. What happens if you're doing a pooled fecal egg count? Well, you want to take samples from 10 different lambs and you're going to take 3 grams from each one of those samples and put them into a container to make 30 grams. You've got to mix that thoroughly, make sure it is fully mixed, and then you take your 3 gram sample that we're going to test from that 30 gram pool that we've made. The next thing we're going to do is add 42 mils of our saturated salt solution, our flotation fluid. Don't inject it too quickly like what you've just seen me do, because what we don't want within that fluid is a lot of bubbles that are going to obscure our view when we come to do the egg counting. So now we've got the flotation fluid in there, we need to homogenize the sample. This just means to mix it up. We need to break up the bits of fecal matter in that sample, and you can do that however you want. If it's very dry, you can use a pestle and mortar to break it up. The main thing is that at the end of the day, when you're mixing that sample, you can see that there are no lumps left in it. The fibre has been completely separated, and what we've got is just a homogeneous mix of the fibre and the flotation fluid. And this means that the worm eggs are now free floating within that fluid. Once we've done that, we're going to pour the mix that we've made through our sieve or our fine tea strainer into our beaker or mug. We're doing that here. You may find you have to give it a bit of a tap to get all the fluid to go through, but that's fine. What we're doing here is filtering out all of the fibre so that what we get going through the sieve is just the flotation fluid and the worm eggs. Okay, give it a mix with the pipette and then draw off what we need from the middle of the sample. Once we've got our sample, we're going to pick up our McMaster slide and we're going to use the pipette to push the filtrate into the chamber of the McMaster slide, and you'll see as if by magic, because of surface tension, that liquid fills up the chamber and it sticks in there. Now, if you've done what I've done here, not drawn up enough to fill up the second chamber, you just go back and get some more, no problem. So we end up with something that looks like this. The next thing that we're going to do is put this underneath the microscope. And once we've done this, we need to leave this slide for about 5 minutes to give the eggs and the cocci in there a chance to float up to the top of the film that we've created. In this time, I would recommend you go and make some coffee, or like me, have a machine do it for you. Now, very important thing to note, I recommend that if you have filtered your sample into a mug, you wash that mug up and remove it from the work area before you take your coffee in there. I do not want to be responsible for any mix-ups of that nature. So here we go. And as if by magic, when we bring it into focus, there's a worm egg here. Now, just to explain what we've got here, the lines that we can see on the screen, they are the lines of the grid etched into the top of your McMaster slide. Okay, so let's have a look at some of the things you might see. This here is a strongyle egg. So this is one of the run-of-the-mill worms, could be a Trichostrongylus or a Teledorsagia, could be a Haemonchus. They all look pretty much the same under the microscope. Let me show you now, before we move on, a coccidial oocyst. Okay, look at the difference in size. These are at the same magnification. You can see that cocci is a lot smaller than the worm egg. It looks like a tiny egg shape there. I'm going to show you one in more detail in a minute, but now let's just look at a Nematodyrus egg. This is the one egg that you can easily differentiate under the microscope. Look how different that looks. Look how much bigger that is. These are at the same magnification. And the Nematodyrus egg is full of those ball-shaped structures. Okay, so these are the three things that we're primarily concerned with looking at under the microscope. We've got your strongyle egg, which is all of the worms apart from Nematodyrus. We've got your Nematodyrus egg, which we can differentiate very easily, and we've got your coccidial oocyst, your cocci, which is much smaller. Now, there are a few other things that you might see under the microscope that you don't necessarily need to be concerned about. If you see an egg that is a little bit smaller than a strongyle egg and looks as though it's got a worm inside it, and sometimes you see these worms moving inside the egg, that is a Strongyloides egg. You don't have to worry about that, they're not considered pathogenic. If you see one of these round, sort of slightly deflated football looking shaped things, that's Menesia, that's a tapeworm. We don't have to worry about them in lambs either. And finally, if you see one of these oval shaped eggs with two flat edges on the end, that's Trichuris. That again is not considered pathogenic. We can disregard them. It is these three eggs on the top row that we want to be looking for. So we're going to start at the top left of our McMaster slide under the microscope, and we are going to go up and down the chambers, counting the eggs that we see. And as we do so, we're going to make a tally of what we see there. So let's say we've done that and we've made a tally of what we've seen. If you have counted all the eggs within just one side of your McMaster slide because you were short of time or got bored, then each egg that you've seen counts for 100 eggs per gram of feces. If you had more time and you counted the eggs in both chambers of your McMaster slide, then each egg counts for 50 eggs per gram. To give an example of this, let's look at what we've just tallied up. We've got 8 strongyle eggs and we counted those across both chambers in the McMaster slide. 8 times 50, that is 400 strongyle eggs per gram. We saw 2 Nematodyrus eggs, so that's the equivalent of 100 Nematodyrus eggs per gram. And we saw 12 cocci, so that is the equivalent of 600 oocysts per gram. The thing to do next is to wash out your McMaster slide. If you don't wash these out, the salt in that solution will crystallize and you will never get it clean again. And that is literally all there is to it. It might sound complex at first, but once you've done a couple of them, you'll be rattling through them in no time. And if taking samples into the vets or wherever is the stumbling block for you doing routine fecal egg counts, then I would highly recommend collating that equipment and having a go for yourself. For more information on how to use fecal egg counts and how to interpret the results that you get, you want to go back and have a look at our previous video called Fecal Egg Counts. Worth your time? The answer to which, of course, is yes. I will be along with another video very soon, and I do hope to see you there. Bye.